Hi class, this is the introductory lecture to indirect proof that you should be doing in conjunction with your careful study of the assigned reading before attempting the problems. We're going to do this a lot like we did conditional proof, and a lot of the same stuff goes for conditional proof with indirect proof. First of all, we are not learning a new way of doing proofs. We are learning exactly one new rule. That's it. And however, we do so by doing assumptions and discharging those assumptions, just like conditional proof. And like conditional proof, I'm going to start by writing the general form, which I do think it's a small shortcoming of the text that they don't include the general form of conditional proof or indirect proof. So we have some premises, and then we have an indent because we're going to make an assumption for an indirect proof. It's an assumption. We're going to assume not P, and then we're going to have some finite number of steps, and we're going to arrive at a contradiction. A contradiction is only of the form Q and not Q. That is the only thing that's a contradiction. By the way, these don't have to be different. I could assume not C and end up with C and not C. That does fit this form. This just says any conjunction of a well-formed formula and the negation of that well-formed formula. So once I have done that, and this is why it's called indirect proof. Remember, in logic, a couple of things are certain. One, this is a two-value logic, so everything is true or false. So what this is effectively showing is that assuming that P is false, that is not P is true, leads us to a contradiction. Contradictions can't be the case, so anything that entails a contradiction must be false, which means by going through this exercise, we have proven one and only one thing, specifically that P must be true. So assume the opposite of what you want to prove, show that it leads to a contradiction, the end. Pardon me. Literally any proof can be done by indirect proof if you want to, but it's like any other rule in logic. Use it when it's useful, use it when it's helpful. Don't just use it to use it. Generally, we think in terms of when would assuming the opposite be helpful to our conclusion. And then the other thing to mention is, like conditional proof, they don't always make things shorter, but indirect proof just about always makes things easier. Because usually once you have your assumption, you just start breaking things down until you can get to, an M and a not M to conjoin and things like that. To show you this, we're going to start by doing some practices from some of the so-called harder proofs. So let's go ahead and start with some of the ones that were labeled as hard from the additional exercises. So if you remember this proof, both A and B implies C, not C and B. It is the case that not A or E implies O, therefore not O. Well, when do I use indirect proof? A couple of times. One, when I have a very simple conclusion, like usually if it's just a single letter, I'll just start with an indirect proof. So, and that's true whether it's a conclusion or anytime I need a very simple letter. So we know this is the equivalent of O, so I'll just start by assuming not O. So I indent, that is an assumption for an indirect proof. Just like conditional proof, I certainly did not prove not O. That's why it's indented, which means I also didn't prove anything that follows from not O. Well, what follows from it? At this point, very often you could just kind of throw strategy out the window and just start breaking down premises. So you might just ask, what does not O help me break down? Well, Horseshoes are only broken down by modus ponens, so and modus tollens, so I can modus tollens line 3 gives me not the case that not A or E. Lines 3 and 4 modus tollens, and then line 6 I'm going to apply De Morgan. That's line 5 because that's the only thing I can do with the negation outside of parentheses. What else can I do? Well, I could break this down with simp com simp for reasons we'll see in a bit. I actually only need the simp. Line 6. So I've broken down line 3. Then I'll break down line 2 with simp com simp, not C. Just so I don't forget, I always write them out. Simp com simp. This is line 8, 8. Sorry, this is line 2, 2, 8. Then B and not C becomes B. And that one's effectively broken down. And now I just need to break this one down, which I could do with modus ponens or modus tollens. Interestingly enough, I could do either. I could use not C to modus tollens, or I could conjoin A and B in modus ponens. Let's modus ponens. Why not? And because double negation is a rule of replacement, I'm going to go not A and B first, using lines 7 and 10 conjunction. Gives me A and B, line 11 double negating part of the line. Gives me C, using line 1 and 12 modus ponens. Now all of the premises are broken down, and I'm willing to bet there's a contradiction or two here. Yep, there it is. C and not C. So remember, the last indented step of an indirect proof has to be a conjunction of P and not P. That could be individual letters. You could very easily conjoin A or B and not the case that A or B. That is lines 13 and 8 conjunction. And that's impossible, which means the one and only thing I have actually proven is that my initial assumption was false. So since not O is false, O must be true. That's using lines 4 through 14 conditional proof, and then double negate for the win. All right, there's several things I want to say about this. I guess the first thing I'll say is I apologize for not having that on the camera. Feel free to pause there and write it down. But there's all the steps. So overall, this isn't significantly shorter than if you did it the long way without indirect proof when we were doing 3.2. But again, we just moved to very, very straightforward breakdown rules like simp com simp, modus ponens and modus tollens, and then putting stuff together with conjunction, instead of actually really scratching our heads with strategy and trying different things and running into dead ends and things like that. So that's why indirect proof is nice. That's thing one. Thing two, it doesn't matter which contradiction you generate. It is a trivial fact of logic. It's actually called explosion, that from one one contradiction, all conclusions follow validly. As such, if you can generate one contradiction, you could generate all contradictions. As an example, if I'd have done modus tollens instead, if I'd have used not C for modus tollens, then I'd have ended up with not both A and B, which is not A or not B. I could use with line 7 to disjunctive syllogism not B, and then I'd have not B and B. Or I could double negate in disjunctive syllogism with not B and get not A, which means I could conjoin not A and not A to get a contradiction, or double negate first and get A and not A as a contradiction. So those are three contradictions right there. As a fourth, if I accidentally got not A without realizing I had a contradiction, then I could do not A and an addition of E to get O, and then I'd have O and not O, which is just as impossible. So one contradiction entails all contradictions, which is why I generally don't look for one specific contradiction. Instead, I just start breaking down until I get to individual letters, is kind of the strategy I employ with indirect proof. Speaking of strategy, there was one thing I did here that I pretended to do by accident that I would not recommend. Remember, these proofs can keep. Remember, these proofs can keep going. So let's say I needed to work some more lines here. I can't refer to anything I did here, which means if I needed not C again, which is perfectly derivable from line 2, I'd have to do it again because I'm not allowed to refer to an assumption. And so things like steps 8, 9, and 10, I would actually not do under the assumption. I'd do them first before I made any assumptions, and that way if I needed them again later, I would be able to have them. So in general, if you don't have to do it under the assumption, don't, because it could just create extra steps. All right, so that's one example of indirect proof. Let's do one more and then call it a day and let you work on these on your own. So I am going to go to, let's just do one of the very hard ones. So if you remember this monster, I'm not sure how many of you got it, which is to say this video is shot long in advance. I'm trying to show that F follows from that mess. So when I'm looking at a single letter, if I want to generate a single letter and I don't see an easy way to do it, whether it's as the conclusion or in the middle of the proof, I simply ask, well, would having not F let me break down some lines? And I say, of course it would. It would actually let me break down lines 2 and 3 by modus tollens. So my first step, probably without even thinking, is to simply assume not F, although remembering what I just told you, if there's a step you need to do that is independent of the assumption, do it first. So the first thing I'm going to do before I indent is use exportation on line 2, because that way I don't have to do this within the assumption. So now not F helps me with breaking down both of those lines. So we're going to assume not F for an indirect proof. And again, you're just looking for any contradiction, if you like to take a side note there. And usually the easiest way to do that is to just start breaking stuff down. This lets me do modus tollens with line 3. So line 3 and 5, modus tollens. If P, then Q. Not Q, therefore not P, should increase the number of negations, which means it ends up at not, H or I. And then, of course, I'm just going to do the second line while I'm thinking about it. H or I, line 6, double negation. Don't know if I'm leading it or not, but sure makes things prettier. Then what? Well, now I can also do a modus tollens with line 4. And line 3 modus tollens gives me not both H and I. And that is something that if I want, I can do a De Morgan there. But notice De Morgan doesn't actually give me the opposite of this. So what would the opposite of this be? Not the case that H or I. So those are pretty broken up. Again, I can run the De Morgan through if I want, but that actually adds a symbol instead of takes away. And I generally don't make things more complicated unless I see a clear use for it. One thing I'll notice, though, is I haven't done anything to premise 1. And there's 2 things I could do with a triple bar. I could say both or neither. Or I could say if H then I, and if I then H. Which of those seems more useful? This is a good place to use a both or neither. Once more, I probably should have done this before I did my assumption, but too late now. So I'm going to say both or neither using line 1, equiv. Why did I do that? Because I can immediately do a disjunctive syllogism and get not H and not I using lines 9 and 8 BS. If you don't believe me, do the check. Is line 9 of the form P or Q where the main operator is a wedge? Yes. Is line 8 of the form not P where it's a negation of everything before the wedge in line 9? Yes. Then I turn my brain off and I write Q. What's Q? Everything after the wedge. Go me. Do I have a contradiction yet? Probably, because by the truth tables, I know that 7 and 10 somehow contradict each other. Why? Because this says one or the other must be true. This says neither is true. So I'm going to work with 7 and 10 to make a contradiction. There are several you could make here. I'm going to take the laziest one. That is also a good learning opportunity. By De Morgan's, this says neither. And now this is of the form Q and not Q. So H or I, and not the case that H or I. That is line 7 and 10, conjunction. This is impossible. This is just as impossible as A and not A. Remember, what does Q or and not Q say? It says any well-formed conjunction whose second conjunct is a negation of the first conjunct, which is exactly what we have in line 12. This all followed from the assumption of not F, which means it must be the case that F is indeed true, using lines 5 through 12, indirect. Way easier than not using that rule. I will say something, though. If you didn't see the line 12 that I did, that's okay. It just means a couple more lines, which are easy to break up. So you could do simp, com, simp, and then do a disjunctive syllogism. If I simp, com, simp, disjunctive syllogism line 7 means I have an I from here and a not I from here. Or I could do that backwards, do a disjunctive syllogism and get H here and not H here. So again, from one contradiction, all contradictions follow. But anyway, I think I said enough on that now. If not, remember, use your resources. Make sure you're using the questions about materials. Make sure you're scrutinizing the assigned reading carefully. Next video will be basically the exam 3 practice. Here's a proof, do it in the best way. And so try really hard and do your best before we get to that. The last thing I'll do today is do a few strategy. This is not just using conditional proof and indirect proof. When do I use them? And how do I use them? If I have a horseshoe, I do a conditional proof. If I need a triple bar, I'll do a conditional proof twice. If I have an atomic statement, I'll use indirect proof. But we haven't talked about wedges and dots. Well, if I have a wedge, if I'm trying to conclude a wedge, I use indirect proof. Why? Think about it for a second. Say I'm trying to prove A or B. If I assume it's opposite, that actually gives me a lot to work with, because what's the opposite? Not A or B, which is logically equivalent to not A and not B, which means I have a not A to work with simp and a not B to work with ComSimp. And so with a negation, with a wedge, it gives me two simple atomic statements to work with. So if I see a use for not A and I see a use for not B, I'll just immediately do that instead of, say, addition or constructive dilemma. What about and? You don't want to use an indirect proof immediately with and. Why? Because if I have A and B, what's its opposite? Not both A and B, which is the same as not A or not B, which is rarely useful. However, what I'll do instead, if I want to prove A and B, if it looks useful and promising, I'll assume not A first, do one indirect proof to prove A, and then I'll do not B, do another indirect proof to do B, and then just conjunction at the end. So really with ands, I end up doing indirect proof times 2. So strategically, if you're looking for good uses for indirect proof and conditional proof, and they save you effort. So remember, if we were doing easy inferences, then you still just want to be using whatever rule is helpful from 3.1 and 3.2. But overall, strategy-wise, those are some very good uses for conditional and indirect proof. And so again, I'll turn you loose. Practice, practice, practice. Make sure you're able to do these instead of just playing the Not Along with Mickey game. Work as hard as you can on the practice problems before watching the practice video, perhaps, or again, whatever works best for you. But just make very sure that you're doing it in a way that maximizes your ability to do these proofs on your own. And we will just see you for some practice next time. Bye.